For more updates, click on subscribe and click on bell button for latest notifications. Hi friends, welcome to Tech Arkit YouTube channel. My name is Ravi. In this video session, we are going to see that what is the difference between vertical and horizontal scaling. So this is very important to understand if you're working in a architectural role or a administration role. So how the horizontal and vertical scaling works and what is their advantages and disadvantages when you should use a vertical scaling and horizontal scaling methods in deploying the servers or designing the architecture. Let's see what are those vertical and horizontal scaling here. So first of all, vertical scaling. Vertical scaling is also referred as a scaling up, is the process of increasing the processing power of a single server or a machine by adding more resources such as CPU, RAM, or storage. This is entail upgrading the server's hardware to handle the increased load. Example say, so if you have the single server, your resource is not good for farmings. Like example, if you're running some server, so the what are the process you're running, it's slowing down. So what you have to do? So you have to add more RAM, more CPU cores, more storage to perform better. So vertical scaling is commonly used when a single machine can handle the entire workload but requires additional resources to handle an increase in traffic. The single server can handle entire workload, but when there is a resources been increased, example there is a increase in traffic, then you have to upgrade the resources like adding the more RAM and more CPU cores and adding more attaching the more drives. Like example, SAN lengths might be increased, or you have to add the additional hard drives to increase the capacity of that. So that's a vertical scaling. So what is horizontal scaling? Horizontal scaling is also known as scale out. Is the process of adding more servers or machines to network in order to distribute the load among them. This is necessitates the addition of more machines to handle the increased traffic. When a single machine cannot handle the entire workload, horizontal scaling is typically used. Example, in this case, you're not adding more CPU or more RAM to the server, so you're adding a parallel server to the environment. Means the single machine cannot handle the entire workload, so you are adding the more machines, one, two, three, four, five, something like that. That is called say horizontal scaling. Let's say what is the example here. If you see that, so how the vertical scaling grow. So vertical scaling means if you see the V, so the V is growing like this. So if you see the arrows, the V is growing something like this. That is called as a vertical scaling. So it's easy to remember that what is a vertical scaling, how the vertical scaling grows. If you see the V, then the V is growing at top, right? So that's called as a vertical scaling. Horizontal scaling, so the horizontal scaling is always a edge growing something like the elastic band, so that is called as a horizontal scaling. So if you see that, so horizontal scaling means like adding more servers to the existing environment. So let's see what is the a simple example here for the vertical scaling. Suppose a website is experiencing slow response times during the peak traffic hours. Like you are expecting 100 users, but there are 200 users accessing the website. So that time the peak traffic, the site response is slow. In this case, the website owner might upgrade the server CPU or RAM to handle the additional traffic, allowing the website to handle more requests without slowing down. So what you have to do, so you have to bring down the server or add the hard swappable hardware on the go, like pull out the server and add the more CPUs and RAM. Then you can boost up the server memory and the CPU circuits and the storage to serve the users more better. So that is the vertical scaling example. If you see the horizontal scaling example, suppose you have a popular social media platform is experiencing slow response time during the peak traffic hours. In this case, the platform might add more servers to the network to handle the additional traffic, allowing the platform to handle more requests without slowing down. So here, whenever you are using the horizontal scaling, basically you don't need to bring down any server. So you just add the more another server to the same platform and expand that resources by adding the one more server to the existing resources. So that's called as a horizontal scaling. So the difference between this here is that the vertical scaling is you have to add more resources to the existing server. Horizontal scaling is you have to add more servers to the existing resources. So that's the difference between the vertical and the horizontal scaling. Let's see what are the advantages you have between this. So if you take the vertical scaling advantages, simpler management without with only one server to manage. Vertical scaling is often easier to manage than horizontal scaling. Example says so the here you don't have so many servers to handle or so many credentials to remember all this stuff. So it's a single server which handles the all the workloads, so it's easy to remember and simpler to manage. Cost effective for small applications. So vertical scaling can be more cost effective for small applications that don't require a large number of servers. Example, for the small applications like you are hosting a small site for the your organization website. So it is something like they comes and inquire you about your services and they get your contact details and your location details and all. So that's a smaller application which does not require to be a highly available or the high-end server. So that in that case, it's going to be a cost effective for the small applications. Highly availability. So high availability, vertical scaling can provide high availability as there are only one server to keep up and running. So that's the option here. And in real time industry case use case, so where it actually provides that a small e-commerce business that experiences a sudden spike in traffic during the holiday seasons might use vertical scaling to add more CPU memory storage capacity to their single server to handle the increased traffic. So that is the a real-time example how these vertical scaling can grow and provide the services. So what is the advantages if you take the horizontal scaling? It is a high scalability. Horizontal scaling can scale infinitely by adding more servers to the network, making it ideal for high traffic applications. Here, if you are getting more traffic in this case, you just add the more servers, more servers, more servers, then it provides the highly scalable environment. Fault tolerant. So example, one hardware is fault. So you have the multiple servers to do this tolerance. Example, horizontal scale has built-in fault tolerance has if one server fails, traffic can be automatically redirected to other servers in the network. So that is the fault tolerance available on this horizontal scaling. Cost effective for large applications. So it is not cost effective for the small applications because a small application is like few hundred users, but you are having more and more servers, then that's going to be a not cost effective solution. But in this case, a large scaling applications, it's going to be a cost effective for the large applications. Horizontal scaling can be cost effective for large applications that requires a significant amount of resources. So that's the cost effective advantage on horizontal scaling. So in real time industry, so what is the example here? A popular ride hailing service might use horizontal scaling to handle the high volume of ride requests during peak hours. By adding more servers to their network, they can handle the increased traffic without slowing down the application. So this is the major advantages between two um, scaling methods. One is on a vertical and another is on a horizontal scaling. Let's see what is the disadvantages if you take. So where you should not use basically the vertical scaling and horizontal scaling. So here limited scalability. Example, say if you take the vertical scaling is limited scalability. So any server cannot grow infinitely, right? Any hardware will have some limitations. Example, the some hardware can only support 512 GB of RAM and 64 cores only, and you can only have certain like 14 terabytes of storage, only 50 terabytes of storage. You cannot grow more than that. So that is the limited scalability here. So vertical scaling has limit to the amount of resources that can be added as to a single server, which can limit scalability. So that's the scalability disadvantages here. Single point of failure. Example, with only one server, vertical scaling as a single point of failure, which can be problematic for high availability applications. Example, if you have the single server, that server is failed, then the application is down. So that's the single point of failure for the vertical scaling. Expensive for large applications. You cannot maintain the large applications in a vertical environment because you cannot grow much. Vertical scaling can become expensive for large applications that require a significant amount of resources. So that's the disadvantages here. So if you take the real-time industry case, a large social media platform with millions of users might find that vertical and scaling is not cost effective or practical, because if a million users are accessing the website, a single server cannot serve that much of traffic or that much of bandwidth to the users to provide the access to the social media platform, as they would need to continually upgrade the servers to handle the increased traffic. So it can grow until the hardware limit says. If the hardware limit comes off, then you cannot go behind that. So what that time what you can do, you cannot do anything. You have to wait to users to reduce or the users to sign up from the social media platform. So that is a bad idea for the users. So because our business is affected if the platform is not running. Okay, any users is not interested in slowly scrolling websites, right? So it should be fast and snippy whenever it's loading. So what is the disadvantages if you take horizontal scaling here? More complex management with multiple servers to manage. Horizontal scaling can be more complex to manage with than vertical scaling. So of course you have multiple servers, you have to handle all of their hardware, network, bandwidth, and everything. You have to manage your inventory and what server is connected to which application and all the details. So that's the complex environment when you are managing that. Requires load balancing solution. Of course, you cannot simply redirect this traffic to the multiple servers without having the load balancing technique or the load balancer devices, something like this. Horizontal scaling requires load balancing to ensure that traffic is distributed evenly among servers in the network. Higher initial cost, so you have to purchase lot more servers. Example, if you want redundancy, of course you have to spend at least 3 or 4 servers. First you have to purchase, then configure them, right? Horizontal scaling require multiple servers, which can result in higher initial cost. Of course, in real-time use case, what is that? A cloud-based file sharing service might use horizontal scaling to handle a high volume of users uploads and downloads. By adding more servers to their network and load balancing traffic, they can handle the increased traffic without slowing down the service. Example, if a one industry, the one company is providing file sharing services like uploading and downloading the files. If more users are uploading and downloading at the same time. So what they can do, they can add more servers to the environment to speed up their upload and download process. So that's all about the vertical and horizontal scaling and examples, advantages and disadvantage about this video. Thanks for watching. Stay tuned. Please subscribe to the channel for more upcoming videos and courses. Stay tuned. Please do share with your friends. Click the like button. Comment your question if you have any, so that we'll answer all the comments. Please follow us on social networking sites. One is Facebook. The Facebook page name is @Linux ARKIT. You can click on this button here and click like page so that you can follow us on Facebook. The next one is Instagram. Instagram name page name is arkit.co.in. Click on follow button to follow me. And Twitter, if you have any questions on subject line, or if you have anything, you can just tweet me at ravikumar48, so I will reply you most on the tweet back. For anything related, if you want to latest articles on my website, so here is my website details and email address details. You can reach me over here.